Hi, my name is Chris Young. I'm here to talk about chemistry. Yes, Chemistry 101. Today I bought this book, S1 International for Chemistry by Lecky, the education publisher for Scotland. Chemistry is, yes, very interesting because you never know what's going to happen. Anything can happen in the next 20 minutes. I remember having a chemistry set when I was a kid. I didn't do it properly. What I did was basically I built a fire and I threw all the chemicals into the fire in one go and saw some pretty colours in the flames, and I thought that was quite nice. And after about 10 minutes the whole thing was used up, and I thought, well, that was fun. But I'm sure I would have learned more if I'd paid more attention to what chemicals I was throwing in the fire. And also I wouldn't well, I fortunately didn't have any accidents, but safety first, guys. Come on, don't do that. Don't be a Chris Young. Okay, so what did we learn from chemistry in Unit 1 of this lovely Lecky book? Well, talking about what is a chemical reaction, and you can tell if something is a chemical reaction if one of four things happen. This: a colour change, a solid being produced, a temperature change, and a gas being produced. So these are four ways that you can tell that there's been a chemical reaction. Okay, let's give some examples. Just like magnesium burning in the air, a bright white light and white solid is formed. Magnesium is burning in the air. Okay, so that's a chemical reaction. Another example of chemical reaction is zinc and hydrochloric acid. Put some zinc and hydrochloric acid, bubbles of hydrogen gas are produced, indicate a reaction is taking place. Okay, also you could mix lead nitrate and potassium iodide. That produces a yellow solid, which indicates the reaction is taking place. Oh, lead nitrate, of course, is a liquid, a clear liquid, and so is potassium iodide. It's a clear liquid, but when you mix them together, you get a yellow solid. Why is that? I don't know. It's interesting. One of the most interesting things in this chapter is that the egg white, when it becomes a white solid, when you fry an egg white is called an albumin, apparently. That's a chemical reaction. It's not just cooking an egg. Ladies and gentlemen, it is a chemical reaction. But you have to be careful because not all things are chemical reaction. That's going to be tricky. Something you need to watch out for. For example, putting nail varnish on your nails is not a chemical reaction. No new substance has been produced. When hot tea cools, there's a temperature change, but no new substance is produced. So, and it's asked four things. It's asked if these four things are chemical reactions. The first one is baking a cake. Is baking a cake a chemical reaction? I've said probably. Because a solid is produced, and also there are eggs involved, and as we've just seen, if you fry an egg, that's a chemical reaction. So if you bake an egg, that's probably a chemical reaction as well. Boiling water, is that a chemical reaction? First I said yes, but then I said no, because gaseous water is still H2O. It's just in a different form. So I don't think it's a chemical reaction. I think it's a physical change. Paint drying. Well, that sounds like an exciting experiment. No, I said, because dry paint is just the same as wet paint, except dry. And digesting food, I said yes, probably it is, because gas is produced and a solid is produced eventually. So there you have it. And the next section is all about changing the rate of a chemical reaction. Now, if you're like me and time is of the essence, you want to do things faster. So learning how to make chemical reactions react quicker is probably to your advantage. Now, according to the book, there are four ways of doing that. Any idea what they might be? I'll tell you what it says in the book anyway. It says First one is, I'm trying to remember what is the first one again. I can't remember if it's the first one, but concentration of the things that you're mixing together. For example, if you're putting magnesium in hydrochloric acid, it will react faster, producing bubbles of hydrogen gas, I believe, if the hydrochloric acid is more concentrated, i.e. it's more concentrated. Temperature. If you heat up a test tube with the magnesium in the hydrochloric acid, then that will also make the reaction happen faster. I wonder if stirring it would help. That's not one of the options, but I seem to remember stirring something helps. Like if you stir sugar into coffee, it absorbs faster. So anyway, stirring is not one of the suggestions. Yes, hello Coco. This is my dog, Coco. Coco, say hi to the people at home. Oh man, this is all happening now. Do you mind? I'm in an important video at the moment. Right, you're gonna fall off the back of the chair. What is she doing back there? You're looking at the printer. Where you at? Where was I? Yes. So, increasing the concentration of the acid, also heating up the acid. And the third one was, the size of the particles of the magnesium that you put in the acid. If there's more surface area, i.e. you put in granules rather than a chunk, then it will happen faster, because we all know it's faster to dissolve small chunks. Small chunks of something than big chunks. So that's probably the same kind of situation. Okay, got that, Coco? Are you listening? Yeah. And fourth one is, of course, using a catalyst. And the example in the book it discussed was some kind of peroxide, I believe. What was it? Hydrogen peroxide, wow. And the catalyst is manganese dioxide. Oh! Manganese dioxide. It's a catalyst. Have you put that in? Then you get more bubbles. Why do catalysts work? I don't know. It doesn't say. It just says that they do, and they're left over at the end. They're not used up in the reaction. They're not. How does that even happen then? Catalysts in the real world, you might have heard of catalytic converters, which help to improve the efficiency of your vehicle. And also, did you know there was such a thing called catalytic clothing? Catalytic clothing is where denim jeans are coated with some kind of substance and then hung out to dry, and the substance in the jeans helps to break down the pollutants in the atmosphere, which is pretty cool. So that's basically as far as we've got with chemistry. I think that's quite enough to be going on with for now. But I did higher chemistry. I'm pretty sure I got an A in that as well. And I mean, moles. I remember moles and test tubes and Bunsen burners and things like that. And safety goggles, you have to be very careful. Nothing dangerous happened to me, fortunately, in chemistry, apart from falling off my stool once, I remember. But that was nobody's fault but my own. And we weren't even doing an experiment at the time, so I was probably swinging on my chair. Kids, don't swing on your chairs. Right, Coco? Don't swing on chairs. That's the moral of the story there, right? Okay, that's the end of Chemistry 101. Thank you for listening. I hope you found it really useful. and or amusing. We'll see you next time. Goodbye.